Hello everyone, welcome back to another GIS Mathematics lecture video. And in this lecture video I want to walk through the most simple case that works for multiplying matrices. And that is this idea of multiplying a row vector times a column vector. And hopefully in the process of doing this, multiplying a row vector times a column vector, we can have a better understanding of why those inner dimension, outer dimension stuff that we talked about in the previous video, why that actually matters. So let's take ourselves a row vector that we are going to call u, and let's give it A, B, and C. Okay. Let's have a column vector, which we'll call V, and let's give it values D, E, and F. Okay. So what happens when we multiply U times V? Right, this is a row vector times a column vector. Well, let's look. So U has dimensions, right? It has one row, 3 columns, right? It's a 1 by 3. That's what it means to be a row vector, right? One row. V is a column vector that has 3 rows times 1 column, right? That's what it means to be a column vector. So what are the dimensions of UV going to be? Well, if we scroll back up to the previous video where I went through a whole bunch of explaining about dimensions and we didn't actually do any multiplication, right? I said that if the inner dimensions match, then the resulting matrix will have dimensions equal to the outer dimensions, right? So again, inner dimensions match, we're good to go. The resulting matrix will have the dimensions of the outer dimensions. So in this case, AB had 3, 4. If this is complete nonsense to you, please go back and watch that video, come back, and then hopefully we can reinforce that with what we're about to talk about. So let's go back to multiplying a row by a column. So we have 1, 3 times 3, 1. Okay, so 1, 3, 3, 1. The inner dimensions match, right? The inner dimensions match, so we're good. So then the resulting matrix here is going to have 1 by 1. Well, you might be saying 1 by 1, that's just a number. And that's exactly right. A row vector times a column vector is going to give us just a number. Well, how do we take this 1 by 3 and 3 by 1 matrix and get just a number? Well, we do that. There's actually an equation that defines how we do this. Okay. So basically what we're going to do is we're going to have a summation, and we're going to walk through this again. So if this doesn't make sense immediately, that's okay. We're going to walk through an example and explain what this means. So in order to convert UV to just a number, right, we're going to do something where we're actually going to sum up UI times VI from I to N, right, where N is the inner dimension. Right, so in this case, it's going to be 3. And that's why this inner dimension has to match. Because if they don't, then this whole equation falls apart. Right, so if we have UI times I, and this is going to be the ith element. Okay, so this equation, hopefully it makes sense to you. If it doesn't, that's totally understandable. Let's take a look at what this means for our conceptual example, and then really quickly run through an actual example. Okay. So, what does this mean? Well, the summation from I to n of ui vi for this particular case, right? Summation just means to add things together, right? 1, so when I is equal to 1, right, we have the first element of u, which is a, times, right, we're multiplying together, times the first element of the column vector, which is d, right? This right here, right, this piece right here, this is when I equals 1, right? And because we're summing, right, we're adding to that, right? When now I equals 2, right, it's going to be b times the second element of the column vector is e, right? This piece right here, right, this is I equals 2, and then we're adding, right, because this is the summation. When I equals 3, right, we have c, which is the third element of the row vector, times the third element of the column vector, which is f. Okay, so this piece right here is I equals 3. Okay. Hopefully that makes sense. Let's give ourselves a little bit of room here and see if we can go through an actual example. I'm going to try and leave that up there a little bit. And so what I want to do is I want to define u as the vector 1, 2, 3. And I want to define the column vector v as -2, 4, 3. So now let's go ahead and let's put this equation into practice here. All right, so we have a 1 by 3 times a 3 by 1, right? The inner dimensions match, and our result is going to be a 1 by 1, which again is just the number, and we're going to employ this equation. So let's go ahead and employ that equation. Right, so the first thing we're going to do is we're going to multiply the first element of the column of the row vector times the first element of the column vector. So that's 1 times -2 plus the second element of the row vector times the second element of the column vector. That's 2 times 4 plus we're going to do the third element of the row vector times the third element of the column vector. And that's going to be 3 times 3. So -2 plus 8 plus 9 is going to be equal to 15. Right, so that is the summation of a row vector times a column vector. Okay, so hopefully that makes sense. Again, if you don't understand this equation, hopefully this example clarified it. If you have any questions, please reach out. Thank you.